Emotional torture. What should I do to make your life easier? Cancel class, cancel exams, cancel everything. Everybody here? That's easy. Make my life easier. Then maybe just extending all the way back to extending logic all the way back to the day you enter. Wish just give you your degrees and take your money. Right? Sorry? Who won't be happy? I know. Yeah. Please stop talking.
So I've heard that a lot of employers say that most of what you learn is on-the-job training. So what's the point of having a degree?
I have a very good answer for that. So then why do you go to school at all? Maybe you just play for 18 years and then start working and you get paid for a job. Right? Why do you want? Did I ever tell you why I teach you whatever I teach you? I don't know. Sorry?
So you think?
Make you think. The purpose of education is not to make you, you're not technicians, okay? Technicians are the people who get trained on the job, trained to do what they're going to do for the rest of their lives. You're not technicians. Are you technicians? No. Education helps you think. Education changes you as a person. Brain is honestly like a muscle. If you don't use your brain, it's really not going to do you much good. If you keep using it, there's so many studies for that. As young as 2 years, 3 years, 4 years, the kids that just use their brain more, they form more connections and eventually it helps them. Same with you all. Learning never stops. Learning is not about learning transport. It's not about how to solve differential equations. Those are just different pathways. You can actually you can be very, very smart by learning many different things. And I really strongly believe that a person who never knew anything about engineering, but was extremely good at some entirely different field, could learn engineering very quickly. You guys can learn economics very quickly. You can pick new things if you know how to think, how to analyze. So, yeah, process economics, I have to teach you certain things because you have to do a little bit of problem solving in this particular area. But in the end, honestly, it doesn't matter what I teach you as long as I teach you something. We communicate, we exchange ideas, right? You use your brain to solve, you think. So my goal, honestly, I think I said this many times. Everything I try to do in a class is to make you think, make you communicate with me, make you communicate with each other, make you use your brain. Because in the end, that's all there is to education. So yes, you're right. You can learn how to design a heat exchanger, when you are working for your company. But you may not be able to design the next generation heat exchanger, something that is better than what they're already using. Right? You may not be able to do out of the box. Challenge the current way of thinking. You will not be able to do any of that. If all you do is go to the company, learn what they're doing, and just keep doing it, right? Is that what you want to do? No. There you go. So yeah, so you come to the class not to really learn exactly the concept you're learning. That's just a pathway, right? Ends justify the means. We are drilling these things into you. Partly because, that's how the curriculum is structured, so that you learn eventually what you need to be a chemical engineer. By my opinion, that goal is a very, very short-sighted goal. That should never be the goal of any program. And certainly it's not the goal of our program in this department. Right? Yeah, you're right. You will never have to solve Navier-Stokes equations for the rest of your life, many of you. We still teach you Navier-Stokes equations. You will never have to solve partial differential equations for the rest of your life after you graduate, but we still teach you. Because that just changes the way you think. Okay? Now we can have a discussion about this if anybody kind of has a different opinion or kind of wants to support me in what I'm saying. I really feel passionate about this subject, yeah.
So can we do like a class where we solve riddles or stuff? Because I feel like solving
riddles. Okay, I'll give you a puzzle to solve. What puzzle are you doing? So there are two mathematicians talking to each other. Okay, one is called Mr. Sum, one is called Mr. Product. So what is Mr. Sum? What is Mr. Product? Okay? I step into the room and I want to have a little bit fun with them. Plus, they were not talking about anything. They both are completely geeky. They don't know what to talk about. So I told Mr. Sum, I go to Mr. Sum and I in his ear, I tell him, I'm going to tell you sum of two numbers. Both numbers are between 1 and 100. Okay? So I tell Mr. Sum, I'm telling you the sum. And then I go to Mr. Product and say, Mr. Product, I'm telling you the product of the same two numbers. And then I leave the room. And then I watch through a glass and look at all the fun that's happening. So, Mr. Product says to Mr. Sum, Mr. Sum, I do not know your sum. So Mr. says to Mr. Product, I know you do not know my sum. Then Mr. Product says to Mr. Sum, now I know your sum. And then Mr. Sum says to Mr. Product, I know your product. So what are the two numbers? Like the puzzle?
That's good.
Think about it.
It's the same two numbers.
Yeah, same two numbers. The idea, of course, this is, the way I said it is highly cryptic, right? But you can convert these cryptic words into very simple mathematical statements. Let me just go through the first one, because the first one is very simple, right? Mr. Product says to Mr. Sum, I do not know your sum. Now, product knows the product, right? It's a product of two numbers. If both numbers are prime, then Mr. Product right away knows the two numbers, right? And if he knows the two numbers, he knows the sum. So the first statement obviously means both numbers cannot be prime, right? Right? So that's the mathematical equivalent of the statement Mr. Product made. Now now the interesting thing is, it's very interesting to think and then think about how you're thinking. It's a beautiful idea. It's a beautiful thing. So you can also start thinking about, it's almost impossible, right? But nonetheless, it's sometimes useful to figure out, how do I come up to this conversion? How do I convert this statement, a cryptic statement, to a mathematical description? What parts of my brain I'm using? The interesting thing is, it's not a linear process. There is no way to describe how you do this. You just do it. Those are the kind of problems that are most exciting, where there's no way to explain to you how to solve it. So what we do is we give you the tools and eventually say, figure it out. Because that certainly requires highly nonlinear, complex thinking, which eventually is the best way to do anything. Okay, so that's the first statement, right? The second statement, Mr. Sum says to Mr. Product, I know you do not know my product. What it means is, the sum is such that the sum cannot be expressed as a sum of any two prime numbers. Because if the sum had a sum that could be potentially a sum of two prime numbers, there is no way for him to not know, there's no way for him to be sure that the two numbers are both prime, right? In which case, Mr. Product could have those two. So there's no way for Mr. Sum to be sure. So the second statement basically means the sum is such that it cannot be expressed as a sum of any two prime numbers. Now those two statements already eliminate lots and lots of different possibilities. And then of course it goes on. So yeah, think about it. Sounds good? Now can we go back to the boring subject of process economics? I'm joking! Process economics is not boring. Nothing is boring. You know what? Why? Because once you start thinking, everything is the same. It's all about taking ideas in. Education is very simple, right? You take ideas in, you do some analysis, and you push out some product. That's all everything is, right? So once you start thinking like that, don't think of when you will use it. Think of, is it interesting to you? Are you having fun? Right? Don't think about degrees. Don't think about grades. Think about enjoyment. Right? The pure enjoyment that comes out of learning something is amazing. I can only tell you there are two equivalent enjoyments for me. One is that. The other is love for your child. Now, none of you have experienced that, so hopefully someday you'll experience that. But those two are almost equal level for me. So yeah, but both are very, very true pleasures. You just can't explain both of those. All right, okay, so last class I started telling you about depreciations. And I told you that what IRS does is it allows you for a type of depreciation called MACRS. MACRS stands for Modified accelerated cost recovery system. Okay? Because last time, in last class, we talked about 3 different types of depreciation. One was straight line, one was double declining, and the third one was SOYD, sum of year digits. SOYD is never used. The book talks about it, so I kind of mentioned it, but I will not talk about SOYD anymore because it's not even used. So last time we did double declining and we did straight line, right? Which one was better? Straight line. Even though the whole point of starting double declining was so we can get double depreciation, right? But in the end, you saw it just doesn't help. So MSCRS actually takes care of that. What MSCRS tells you is start with double declining, and when the time comes, when a straight line gives you better depreciation, switch to straight line. Okay? And so you will see what that means. So let's say that your decline, so in most chemical engineering equipment is depreciated over a period of 10 years. Now you can apply MSCRS over 7 years, 5 years, the idea is really the same in each case, but we are going to do over 10 years because that's what most chemical industry is. So let's write down the years here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. And you might ask me, why am I writing 11? The reason is because in year 1, usually you have to assume that you bought the equipment in the middle of the year, and so you can only claim 50% of the depreciation, okay? Or you basically look at half a year. So straight line, of course, is very simple. Straight line over 10 years. So let's start again with 100. So how much is the depreciation each year? 10. Right? So first year, of course, will be 5. Right? And then 10, 10, 10, 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 5. Right? This will be straight line. Yeah? Pretty clear. Now let's look at double declining. Now to do double declining, we know that we have to keep computing book value, right? So let's look at the book value here. The book value starts at 100. So what will be the depreciation in year 1 for double declining? You would think it would be 20, right? 2 divided by n, but because you can only claim for half a year, 10. Okay, very good. So 10. So the book value is 90. So what will be here? 18. So this will be 72. This will be 14.4. Can somebody please keep doing this and give me the answers?
57.6.
Okay. So 14. Sorry, what? No. 11.4.
Yeah, actually 1.52, but
1.52. Okay.
so 46.08.
Okay.
9.216.
Just do 2. Okay.
37 approximately.
37. No, we can do a little bit better than that. No, it cannot be 37. 0.28 and 0.22.
Yeah, it'll be 36.4.
36 points?
36.86, I think.
Okay. All right. Next.
How did you get 14.4?
Huh?
How did you get 14.4?
You multiply this by 0.2.
By 0.2?
Yeah.
Oh.
You always multiply by 2 over n. So double declining, you always multiply book value by 2 over n. And n is 10, right? Okay. All right. Next. 7.37. 4. 8. Okay.
It'll be 58.96. 5.896.
5 point.
896.
Okay.
23.9.
Sorry. 20 what?
23.58.
Okay, and you can calculate the rest, but you will see why I stopped here in a second, okay? So now let's calculate the straight line. Now you might say, but you already calculated the straight line. But the idea is that once you start claiming double declining, you have to readjust those straight line, right? You cannot suddenly say, well, you know what? At this point, I switch to a straight line. Because this straight line was assumed on the basis of, right? Because now what does straight lining mean? Straight line basically means 1 over n times book value. Right? But n assumes the remaining number of years. You cannot take n to be 10, right? Because if you take 10, then of course you're claiming too much depreciation. You can see that. If you add all this up and this up, it will be more than 100. So you can't do that. The idea is that you have to claim straight line on the remaining amount. So let's see what I mean by that. So at this point, right, the remaining is 29.48. And how many years are left? 1, 2, 3, 4, 4.5, right? So you can also calculate straight line or updated straight line. Does that make sense? Updated straight line basically means what would be the straight line updated? Assuming that you've already taken book value, double depreciation to a certain point in time. So like for this point, it will be book value divided by 4.5. So what is this number divided by 4.5? Sorry?
6.55.
6.15. So you can see that 6.15 is better than 5.89, right? So that means after, so you take till 7.37, you take these, and then you switch to 6.15. So at this point, you switch to 6.15 and 1.5. Now of course it will be the same, right?
Do you switch
1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, sorry?
Do you switch in the middle of the year? Or?
No, at the end of the year. So these are the year 1 depreciation, year 2 depreciation, 3, 4, 5, 6, year 7, 8, 9, 10. Of course, last one will be half of that, 3.07. So that's your depreciation based on MACRS over 10 years. Yeah.
So is your goal just to depreciate it as much as possible, as quickly as possible, and then just let it straight line at the end?
That's exactly what you're doing. But no, the government, well, that way you will depreciate everything right in year 1. The government basically tells you what it allows and what it doesn't allow. If it were up to you, you depreciate the entire 100 in year 1, right? But the government tells you this is something they would allow. Yeah.
I'm kind of confused with math. If you take 29.48 and divide it by
4.5.
yeah, you're gonna get 6. I get 6.5. Even if you get 6.15. So
Okay, no, whatever you get, tell me what you get. We'll use the correct one.
It should be 6.5.
5.
Okay. Because now, okay, so now what you do is you have to update the book value correctly, right? But we already know if it's straight line, it's going to be same year to year, right? So we don't have to do this anymore. But if you want, you can keep updating the book value and eventually it will go to 0. You want me to do that?
No, I got it.
So no, actually, let's just do that. So actually, because it will help clarify the thing. So now, of course, the book value will be not this minus this, but this minus 6.55, which is 23 roughly, or 22.9 what? 29.3? 9. And then you subtract 6.55, what do you get?
16.38.
Okay, again you subtract 6.55.
9.83.
9 point?
83.
Okay, subtract 6.55.
3.28.
And there should be half of that, right? 3.28, so you finally get 0, right? As you should. Right? Does it make sense? So that's your depreciation for the 10